Good morning, we're on to lesson 5 notes. We're going to talk about characteristics of sinusoidal functions. Last day you learned about radians. We compared degrees and radians. When you're dealing with sinusoidal functions, it's easier to work with everything in radians. Basically, radians and degrees describe a very similar thing. It's like in the States, they talk about temperature in Fahrenheit, in Canada in Celsius. It means kind of the same thing. But radians are a more mathematical way of analyzing sinusoidal functions. So just as a review from last day, we were talking about angles on a coordinate plane. We are familiar with degrees, that's what you've been using most. But we can also use radians, and radians are a more mathematical way of analyzing it. You can do it either or, but you'll see in this unit when we get to sinusoidal functions, radians work best for graphing and everything like that. So for radians, you can start with 0 radians, 90 is the same as pi over 2 radians, 180 is the same as pi, 270 is equivalent to 3 pi over 2 radians, and then it goes all the way back to a full circle, which is 2 pi. So I went through the chart here in both. I give you radians and I give you degrees here. So I'll kind of show you how we get the values from both. But from then on, most of the stuff we're going to do is going to deal with radians. So we're going to learn about graphs of y equals sine theta and y equals cosine theta. These graphs are very closely related and there's a lot of different information we can get from them. What you'll see if you have the notes in front of you is that they form kind of a wave-like pattern. So we often use these to analyze functions that have to deal with either sound waves or possibly tidal waves, that kind of thing. Even temperature fluctuations, anything that goes up and then down and then up and then down in a repetitive way can probably be modeled by a sinusoidal function. So first we have to figure out how to graph these. So we have a little chart here, a table of values. Theta is like your x. We just usually use theta to represent an angle measurement. So first I want to find out what sine theta is. That's going to be like your y values here. Okay, so in your calculator, it's probably in degree mode because that's how you've been working with things so far. You can type it in and figure out what it is. So first I want to find out what sine of negative 180 is. So we're going to type in sine negative 180. And you can see that equals 0, and that's where I got the value in the chart. And you can do the same with cosine. So cos of negative 180. You'll see it'll give you negative 1. So that's how I'm filling in my table of values. We can also do this with radians. You have to be careful now in your calculator. It's in degree mode now, probably. But what we can do is go into mode, shift down here till radian, and hit enter so that it gets highlighted. Now we can come out, and now when we do our values for sine and cos, you have to make sure you use the radian values instead of the degree values, or else you're not going to get the right answer. So we can even see sine now of negative pi. It's going to be the same thing. But now we're making sure we're using radians instead of degrees. You can see it equals 0, and cos of negative pi should give me negative 1, which it does. So we're going to leave our calculator in radian mode and use that for most of everything in this unit. I filled in the rest of the table of values, and now we can actually graph what this looks like. So first we're going to graph y equals sine theta. So I can see from the chart, when you have it all filled out, I won't fill all of it out, but you'll get the idea here. It follows a pattern. Whoops. Okay, for sine theta, when my theta is 0, my sine value is 0. So that's a point plotted on the graph here. When my theta is pi over 2, my sine is equal to 1. When my theta is pi, my sine value equals 0. And when it's 3 pi over 2, my value will be negative 1. And then at 2 pi, it comes back to 0. This is one full rotation of your graph, and then it just repeats itself. So sometimes when you do one full period, it's called, which we'll get to in a minute, you can just copy your pattern and you don't have to actually think through it again. It's going to follow that exact same pattern. and backwards as well. So this is the graph of y equals sine theta, and we can do the same for cosine. So y equals cos theta, you're going to use your table of values. You're going to see now it's a similar pattern, but when your theta is 0, your cos is going to be equal to 1, and then pi over 2 will be equal to 0, and at pi negative 1, 3 pi over 2 will be 0, and 2 pi will get to 1 again. Again, this is now one full cycle or period of your graph, and then it's going to continue on with that pattern forever. So once you get one done, you can just kind of follow the pattern after to finish your drawing. And make sure you go back as well. Try to fill up the whole graph space when you're drawing these guys. Okay, so that's the graph. You'll notice they're super similar. The only thing with the cosine one is it looks like it's kind of shifted over one unit over, and then it's basically the same as your sine graph. You can check these on your calculator. Make sure your calculator is in radian mode. You can go into your y equals, and if you want to see what sine theta is, just type in sine x. I changed my window slightly. I just made my y min and my y max negative 3 and 3, because if you look, your y value is only going to be between negative 1 and 1 for these examples. And then you can hit graph, and then you can see your curve pattern there. So that's the basic sinusoidal function, but obviously we're going to add some extra stuff to it. So let's go to the next page and analyze some things that we can get from this graph. Okay. So all sinusoidal functions have a number of characteristics in common. So this one we wrote in degrees, that's fine. Most of them you'll see in radians, but either way will work. So here we have a graph and there's some definitions we need to know. So the first one is the uppermost point that the graph reaches is referred to as the maximum. So for example, in this graph here, this point here would be the maximum. You can see it reaches the maximum an infinite number of times if you keep going with this curve over and over. The lowermost point that the graph reaches is referred to as the minimum. So when I look here, the lowest point it gets to here is the minimum. So you can see it has a maximum of 1 and a minimum of negative 1. The vertical displacement refers to the horizontal midline that lies halfway between the max and min values. So in our case here, the exact halfway point between the max and the min is right here. It happens to be the x-axis, but we can shift this graph up or down. This is called the midline. And it talks about your vertical displacement, which we use as d. So in this case, my d is going to be equal to 0 because it's not shifted up or down from the x-axis. It's right on there. So my vertical movement or displacement is 0. Another way you can find this that might be handy later on is it's your max value plus your min value divided by 2. So in our case, it would have been 1 plus negative 1 divided by 2, which is 0. Amplitude. Amplitude, we use a. And it refers to the distance between the midline of the curve and either the max or min. So I want to know how far up or down this curve is going. So from here to here is your amplitude. And I can see my amplitude here is 1. Okay. You could have also found it from your lowest most point to the midline. They'll be the same answer either way you look at it. So that's also my amplitude. The period refers to the portion of the graph which is repeated over and over again. So when you have one full cycle, that is considered a period and then it just repeats itself. So in our case, if I start here, I can see the curve goes up, goes down, goes up, and then it's going to repeat that exact pattern. So I can see this section here is my period. So in other words, my period is 360 degrees, and then it just repeats itself every 360 degrees. Okay, domain of all sinusoidal functions. These curves go on forever. Domain refers to your x values, or in our case, our theta values. Is going to be all real numbers. So your domain here is x belongs to r. It goes wider and wider and wider forever. The range is the y values. In this case, this is a very basic graph of a sine curve. My y values are all between -1 and 1, but this can change depending if you're shifting your graph up or down, or if you're stretching it longer, then your domain could change. So for the above example, my range happens to be, my y values are between -1 and 1. But that one you have to kind of think about a little bit more carefully. Okay, good way to summarize some of the stuff we've done. I found a really good website. Is here. It shows the different angles you can have, and then it tells you up here what your sine and cos value is for each of those. So you can see here, when my angle is 0, my sine is 0, my cos is 1, and then you can kind of trace it all along and see that the values always fluctuate between -1 and 1 for your cos and your sine. And you can even change it back to degrees if you want, and look at that range for all the different degrees and your values for sine and cos as it traces it, and then it also traces the graph on the right-hand side. So if you want to look into it, you can go into that site as well. Okay, back to our examples. I'm going to give you a couple graphs, and then you're going to have to tell me some information about it. So I'll do 2 of these examples with you, and then that'll be it for today. So I'll do the first one here. Here is my graph. I want to figure out all this different information. The trickiest thing to find is usually the period. Everything else is a little bit easier. So I'm going to start with the maximum. Maximum is the highest point your graph gets to, and I can see that's at 6. My minimum is the lowest part your graph gets to, and I can see that's 2. Okay, my amplitude, what I find is super helpful is when I get these graphs, I like to draw the midline in. So I can see that my graph is between 2 and 6. So the exact middle of this graph is going to be at 4. So I like to kind of draw that in just to help me analyze my information. That's usually the first thing I do, because it's going to help you out quite a bit. Once you have your midline, and again, you can kind of find that by doing your max plus min divided by 2. I'll tell you what your midline is. Now you can figure out your amplitude. So from that line, I can see my amplitude is 2. Those waves are going up by 2 and then down by 2. So that's your amplitude. Another way to find that is go max minus min divided by 2. Do that as well. Vertical displacement, that's how far your midline has moved from the x-axis. So my midline is at +4. That means my vertical displacement is up 4, or a +4. Another way you could have found that out is go max plus min divided by 2. You can look at the graph and sometimes just figure it out, or if you need a more technical way, you can use that. Okay, the period is the trickiest part. So what I like to do is I like to try to find a full revolution with points that I can actually read the data from. So I'm not going to start from like here and try and find a full revolution of that, because you're not going to be able to read clearly what the x value is. So this one's not too bad. What I can do is here I'm starting at the top here. So I'm not looking for a full revolution. It goes down, then it goes up, and then it's going to repeat that over and over again. So this is one full revolution. I can read the number very clearly here is 0 degrees, and from here I can see very clearly that it's 180 degrees. So I can see a full revolution took place in 180 degrees. So it repeats itself every 180 degrees. The next one's not too bad. I'll let you look through that one on your own, and then I'm going to do the very last one here. Okay, so first thing I like to do is draw the midline. So I can see the highest point is 8, lowest point is -2, so that is a difference of 10. That means my midline has to be 5 units away from either the max or the min, which means my midline is at 3. I can't draw very straight, but that should be right at 3. Okay, so that's my midline. So now let's do the easy ones first. My max I can see is at 8. My minimum I can see is at -2. I can figure out my amplitude by looking at the graph. It's going to be 1, 2, 3, 4, 5 for my amplitude. And then vertical displacement, I can see that my midline was shifted up 3, so that would be a positive 3. Now your period. Sometimes it's really hard to decipher what your period is, so you have to figure it out as best as you can. So I'm looking for values that I can use. So I highlighted on your page a period, but you can see it kind of falls in between coordinates, so it's really hard to decipher what the period is. So I'm looking for nice points that I can use that will help me. So I can see this one here matches up here, so that's good. A full cycle is going to end up here, which is kind of in between values, so I can't really use that point. So I'm looking for the next nice point that I can use that matches up nicely. And I can see the next nice one is this one here, which matches with this value. So now that I have perfect coordinates, I can kind of use some mathy skills to figure it out. First thing I want to do is I want to figure out how much each tick of these is worth. I can see that 1, 2, 3, 4 of them is 90 degrees. So each tick on my x-axis should be worth 22.5 degrees, right? 22.5 degrees, the next one would be 45, then it'd be 67.5, then it'd be 90 degrees. So now I know how many ticks there are. Okay, now I have to figure out how many revolutions I have within how many ticks, essentially. So looking at this, I have 1 revolution and a half. So I have 1.5 revolutions or repetitions. And how much space did I take to have that? I have 1, 2, 3, 4, 5, 6, 7, 8 ticks. And I know each tick is worth 22.5 degrees. So I know in 180 degrees I get 1.5 repetitions. So if I want to know where I just get 1 repetition, I'm going to divide that by 1.5. That's going to give me 120 degrees for my period. This one was super tricky, and as long as you get close or you're using some kind of mathematical way to get there, then you're probably going to do fine. Most of them are easy to read, but sometimes they're a little tricky and you got to do some side work. That's all we're going to cover today. We're going to go through more characteristics of sinusoidal functions the next day, but I hope you have a wonderful rest of your day.